Okay, so let's talk about selection sort. Selection sort is another comparison based sorting algorithm, right? Here also we compare the elements and then sort them. And it also uses the concept of sorted and unsorted subarray, like our bubble sort. Okay, so here we have sorted array, we have unsorted array, right? Like this. So at each pass in bubble sort, we have the concept of pass. So here also we have the concept of pass. So in each pass, we sort one element by finding the minimum element from the unsorted array. Okay. So in bubble sort, what we used to do, we used to check the adjacent elements, right? So in first pass, we used to check like if this is smaller than next element, if this is smaller than next element, if this is smaller than next element, like this. Okay. But here what we do, in a single pass, we traverse and we find the minimum of all the elements. We find the minimum of all the elements in our unsorted array. So in first pass, we find first minimum. In second pass, we find second minimum. In third pass, we find third minimum. Okay. So here we find the minimum element from our unsorted array. Now, this is the interesting part. It is not stable. What does it mean? See, we are checking the minimum in our whole array. So the sequence of repeating element can change, right? So it is not stable. Now it is in place. Why? Because we are not using any extra space, right? So in selection sort, it is not stable and it is in place, right? These two things you need to take care. Now if you can observe, it is more like same as bubble sort. Now what's the difference? In bubble sort, we were checking adjacent elements, and in selection sort, we are checking for minimum elements. Okay, so let's take an example. So let's say we have an array, let's say 2, 5, 6, 1, 3, right? Let's say we have an array of size 5. Okay, so it will take n minus 1 passes to sort the array. So it will take 4 passes to sort the array, right? So let's take our first pass. In pass 1, we have 2, 5, 6, 1, 3. Okay, so let's index it 0, 1, 2, 3, 4. Okay, so initially I will take my current index as minimum. So minimum is equals to my current index. So let's say 0. 0 is minimum now. So I will check if 5 is less than 2, no. 6 is less than 2, no. 1 is less than 2, yes. So I will update the index. So my minimum is at third index. Now I will check if 3 is less than my minimum. So no, 3 is not less than 1. Okay, so after first pass, my minimum is at index 3, right? So what I will do, I will swap the value at current index. Okay, so this is our current index and the value at minimum index. Okay, so I will swap these values. So after first pass, this will be 1 and this will be 2, right? So after first pass, we have the array like 1, 5, 6, 2, 3. Now this part is sorted and this is unsorted. Okay, so my next pass will start from this place, 1. Okay, so let's run our second pass. In my pass 2, I have elements like 1, 5, 6, 2, 3. 1, 5, 6, 2, 3. Okay, so now I will mark this as minimum. Okay, so 1, 2, 3, 4. So my minimum is 5. Now I will check 6 is less than 5, no. Okay, 2 is less than 5, yes. So I will update the minimum index. So minimum index will be 3 now. Okay, now I will check 3 is less than 2, no. So my pass will complete. Okay, so after this, what I will do, I will swap my array of current index with my array of minimum. Okay, so after this pass, my value will be 1, Okay, 2, 6, 5, 3, right? I will swap my value at current index with my minimum index. Okay, so now pass 3. So in pass 3, this part is already sorted. Okay, so I will start from here. Now mark it as minimum. Okay, so my minimum is now at second index, right? Compare, 5 is less than 6, yes, so I will update my minimum. So minimum will be at index 3. So this is index 3, this is 4. Okay, so now I will move forward. Okay, so I will check 3 is less than 5, yes, so I will update my minimum index. My minimum index will be 4. Okay, now what I will do, I will again swap array current index with my minimum index. Okay, so here value at my current index is what, 2, and my minimum index is what, 4. So swap the value of 2 and 4. So this will be 3, this will be 6. Okay, so after third pass we have values like 1, 2, 3, 5, 6. So this is sorted and this is unsorted. Okay, so again take this as minimum. So my minimum is 0, 1, 2, 3, 4. My minimum is 3. Okay, now compare this with next index. So 5 is less than 6, yes, so no need to update the minimum. Okay, now after this what I will do, I will swap array of current index with array of minimum index. Okay, so I will swap 5 with 5, so it will be 5 only, right? So after first pass the values are 1, 2, 3, 5, 6, right? So after fourth pass we have values like 1, 2, 3, 5, 6. So the array is sorted now. Array is sorted. Now what you can do, you can put a check if my minimum is same as current index, no need to swap, right? Because both are same. So this is about our selection sort. So it works in passes. Okay, so selection sort takes n-1 passes, right? Same as bubble sort. Now what are the total number of comparisons? So total number of comparisons, what we are doing? So in first pass it will compare n-1 times. In second pass it will compare n-2 times. In third pass it will compare n-3 times until 1. Okay, so if you do this, we have done this like 1 plus 2 plus 3 up to n summation. What it is n into n plus 1 by 2, right? So here we are doing the same. Okay, we are running for 1, then 2 till n-1 times. So it will be nothing but n-1 into n by 2 times, right? So it will be nothing but order of n square. So the number of comparisons are order of n square. Okay, now what are the number of swaps? So the number of swaps are n-1 in every case, right? So what we are doing, we are running n-1 passes, right? And in every pass what we are doing, we are doing one swap. Okay, so in n-1 passes there will be n-1 swaps, right? So I hope this is clear, right? We are running n-1 passes. In every pass we are swapping for one time, right? So in every pass, in pass 1 we are swapping for one time, in pass 2 we are swapping for one time, in pass 3 we are swapping for one time, right? So in every pass what we are doing, we are swiping for one time, right? So in every pass we are swiping for one time. So in pass 1 we are swiping one time, in pass 2 we are swiping one time, right? In pass 3 we are swiping one time, in pass 4 we are swiping one time, right? So there are n-1 passes. So for n-1 passes we are swiping for n-1 times, right? So for n-1 passes we are swiping for n-1 times. Okay, so the time complexity is always order of n square. Why? Because we are doing n square comparisons every time. even in best case, let's say 1 2 3 4 5, this is sorted array. Okay, even in this case we are doing n square comparisons, right? We are doing comparisons for this, then this, then 3 4 5, then 4 5, right? So the comparisons will be n square only. Okay, so the total number of swaps will be n minus 1 in every case, in best case, in worst case, in average case, and time complexity will be order of n square in every case, because the comparisons will be n square in every case. Okay, so this was all about selection sort. Let's code it quickly in our Visual Studio Code. Okay, so let's code our selection sort, right? So first take an array of size 5. Let's take it 5 comma 4 comma 3 comma 2 comma 1. Okay, and I will call my selection sort. I will pass the array, and after this what I will do, I will print all the elements. Okay, now I will create a function int arr, and what I will do, I will run a for loop, outer loop for 0, and I is more than my, let's pass the size here. Okay, so let's pass the size. Now I will is smaller than n minus 1. Okay, because we want to run n minus 1 passes. So I plus plus, see, it will run n minus 1 passes. Okay, from 0 to n minus 1. So now what I will do, I will, let's say, take int min equals to my I, right? So I will again run a loop int j equals to I plus 1. Okay, and j will be smaller than n and j plus plus. Okay, now I will check if array at index j is smaller than array at index minimum. Okay, what I will do, I will update my minimum. So minimum will be j, right? And after this loop, after this for loop, I will check what if my minimum does not equals to I. That means we need to swap. Okay, so we need to swap. So let's call our function swap. So I will pass what? I will pass the value of array of I and array of minimum, right? So let's create our function swap. So it will be void swap, like int star a comma int star b. Okay, I am passing it by reference so that it will change the value at this index in our original array. So I will take a temp. Okay, temp equals to the value of a, and a will hold the value of b, and b will hold the value of temp, right? So let's save it and let's run this. So it will be 1 2 3 4 5, right? It is sorted. Okay, let's pass some another values. Let's say we are passing 7. Now let's run it. So 1 2 4 5 7. Okay, so this is printed successfully. So this is our code for selection sort, and time complexity we have discussed. So it will run for order of n times, and every time it will do comparisons. So it will do comparison for n minus 1, then n minus 2, then n minus 3. So total it will run for order of n square times in every case, right? We have done the optimization that we will only swap when the element at minimum index is changed. Okay, so initially I'm considering the minimum element at index I. Okay, if I got the minimum at next index, so I will update the minimum. Okay, so if both are not equal, that means I got the minimum at different index, so I will swap it. Okay, so here I have written the code for swapping. So that was all about selection sort. I hope you understood it. if you don't understood it, just try to dry run it. Okay, just try to dry run it by taking whatever example you want, so it will be very clear to you. Okay. So if you want to refer the notes of this lecture, so you can scan this QR and you will get the notes of all the sorting algorithms. In this notes we have covered insertion sort, selection sort, bubble sort, heap sort, merge sort, quick sort in detail. Okay, so if you have any doubt, you can read these notes. And this was all about this lecture. And